The Spice Hotel is a really good.
No, I haven't read that.
Yeah. Read the Spice Hotel?
No, I
actually. Awesome.
Yeah, I'd like to look at that. So, and then there was also Jerry O'Neill with this book, High Frontier, was talking about the economics for actually having large space settlements. And part of the reason, the motivation for space settlements is to develop the moon and asteroid resources. This is just a reminder of the Earth's and the moon's orbit, and these are stable locations in the Earth-Moon system. There's L1 and L2 are very good for space stations. The Chinese just launched a relay satellite to L2. But if you go out to the moon, you're going outside of the Earth's magnetic field, and you're more subject to flares from the sun and radiation risks from the sun. And so here's the Earth's magnetic radiation belts. And so if you, space station is down here underneath the inner belt. But if you go out to the moon, it's out there. But this is rather, even traditional companies like Lockheed and Boeing are looking at doing really large projects on the moon. They see opportunities. These little green bars down here show that the much cheaper cost of bringing material from the moon to Earth orbit, if you can get that working. And some of the resources on the moon are, from metals to ice, water ice, about 1 billion tons of water at the poles of the moon. They just announced a few days ago that reanalyzing data and finding that there's ice on the surface in these craters that have not seen the sunlight for 3 billion years. And part of the motivation is to provide power to the Earth by collecting sunlight in space and transmitting the power down to Earth with the idea that with flying cars and things like that, we're going to still need a lot of power if we want to do it without contributing global warming. So Lockheed is actually building this vehicle that will be able to land sideways on the moon and get refueled on the moon. And so a lot of people, NASA started a program with a space station around the moon. They've put out $500 million for this first piece right here for the design of it. There's an announcement tomorrow about it. Europe is working on a moon village. This is Bigelow's inflatable habitats on the moon. This is Blue Origin is operating in secret with Jeff Bezos, but he's got really big plans about hundreds of people on the moon. And he's building, we saw the rocket in Seattle. Sideways, it's 3 stories tall. But and here's the Lockheed Martin plan with 1,000 people out of the moon in 30 years. That's the lunar gateway. That's NASA's plan. 4 people out here, but some of these other plans are going to swamp this one.
Is water make a really good radiation shield?
Yeah, water is really a good radiation shield. Yeah.
You don't need about.
And also lunar regolith, lunar dirt, is a good radiation shield. That's why this European one has this inflatable module, and then you just cover it with dirt. I think we're desperate for new concepts and designs in this, because I've seen this same design from the Europeans for 50 times, and it was like, can't somebody come up with a bigger plan for what the next one looks like on the moon? Yeah.
Would it be possible to send a really large thing like the current space station, but different, maybe a bit larger, to Mars, and to get it to land on Mars and fling in to the surface?
Yeah, let me show you some of the ideas for these big vehicles going to to Mars. Just a moment. This is a vehicle constructed, you know, like the idea, once again, with the 3D printing and things like that, where you send the robots ahead to build your base before you arrive. And so there's and this is more of a traditional lander. This is a multi-level habitat inflatable on the moon. And a big issue is growing your own food, and that's something that has not been looked at enough. So there's lots of people have been working on the launch vehicles, the robot, and things like that, but there's not been enough thought about the life support for long-term survival on the moon. Here's the SpaceX BFS on the moon. It's crazy. It's actually, you know, aerodynamic vehicle that lands on the moon, and then it can take off using lunar propellant, or it carries enough propellant to return to the Earth and re-enter the Earth's atmosphere. So it's really a potential for a shuttle back and forth to the moon, carrying about 100 people at a time. And one idea for radiation protection is to go inside lunar lava tubes, which are these maybe half a kilometer across tubes that are on the moon. And it goes back to like the concept of 2001, where you have this giant tube inside, and if you build inside the tube, then you can experience, you know, and pressurize it with an atmosphere. You can experience the 1/6 gravity of the moon, where you can actually fly as a human. You don't actually need stairs. You can jump from floor to floor and things like that. And then with the Mars vehicles, there's lots of different ideas about Mars vehicles and habitats. This is, once again, Elon Musk's spaceship landing on Mars. And so what's crazy is that parts of this are being built right now in California. And so the tank is being built, and he actually thinks he'll be test launching and test hopping this in a year or two. You never know what schedules that Elon publishes, but and actually, they're not showing at all the interior of these things. This is just somebody's idea of what an interior could be. And this is the idea of spaceships landing on Mars. And this, I think it's perfect timing for young folks here to have a ride to Mars on one of these vehicles. Elon occasionally draws this, like all the little habitats that you could build on Mars. And I think this is kind of ridiculous. It looks like SimCity, you know, somebody cut in haste. And so I think there's a big opportunity for architecture and design concepts for Mars habitats. But there are issues with Mars. I mean, right now there's a global dust storm that's cutting the sunlight so much that if you were depending on solar power, you'd be in real serious trouble. One of the areas, just to wrap things up, is I'm a big fan of asteroids. Ever since I started studying in 1980, we used to know about 12 Earth-crossing asteroids. Now we know about 18,363, of which 100 were discovered this last 2 weeks. And so here's Earth right here. At the moment, this is where they are today. This is Mars out here. What happened to Venus? Venus should be around here somewhere. Anyway, I lost Venus.
Up at the top.
Oh no, there it is. There it is. That's Mercury. There's Venus. Yeah. Okay.
Is that 1 o'clock?
And so asteroids come in all shapes and sizes. This is main belt, 100 kilometers across. Here's an example, 4 kilometers across. And this one, this is over Silicon Valley. So there's some plans about, some studies about sending astronauts out to an asteroid when it comes close and then coming back. But there's, in the long run, I think they are great material for building space cities out of, or space settlements like this. And there's also some concern about some asteroids are just crumbling rubble piles, and so with those, if you start digging on them, it'll just be a dust cloud, and they won't. And so there's actually this concept of a bat trying to contain this rock. I mean, this rock is only about 20 meters or 30 meters across, and so you can't do this to the giant asteroids. But this is a proposal to enclose the whole thing and then use gas to de-spin it, and then start moving it around using puffs of gas. So all of these things are these concepts of how to deal with everything in the solar system is brand new and wide open for ideas and different concepts. Just to give you an example, that one asteroid is basically, or one big asteroid, maybe that one I showed earlier, that 4 kilometers across, that's equal to all the buildings on Earth all put together in the material. So that one little dot is like you could replicate all the cities on Earth, and so people have talked about the potential in the future that of material from the asteroids as being the dominating industrial thing. This is an example of greening an asteroid, actually turning an asteroid and extracting the water and making a entire water environment. And so maybe humanity is just the plant's method of going to the stars. I don't know. It's maybe that's our role, is to bring life into the solar system. So as I mentioned, these rockets are being built right now, and they're reusable, so that Elon is thinking that this thing will fly at $7 million a flight, which is enough to actually do a lot of these big projects. And so there's, and not only, this is a design from Jeff Bezos, and he has one that's even bigger called the New Armstrong, but he never shows a picture of it. But, so we're at the verge of a lot of activity, and these people have just worried about the rockets. Everything else about bringing humanity into space activities is wide open and hasn't been worked on. The food production and different energy, robotics and habitats, and how you use asteroid resources. And one other area is that I wanted to connect this with. I see New Zealand as being an amazing example from the history of everything from the Maori arrival and the European arrival, history of 60 years of Antarctic operations, starting to launch into space this year, or this past year, and with a future of moon, Mars, and asteroids. And so I think New Zealand is well suited to play a big role in the future of humanity in space. And so one area that I'm trying to connect with the Maori and Pacifica community is I'm also trying to organize a conference on connecting the history and stories of the settlement of the Pacific with the future settlement of the solar system. So that's it. Thank you. All right, and I wanted to show you one other thing. This beat-up globe on the moon that I added critters to when I was a kid is something my parents gave me, which had, at that time in 1964, there was an unknown region of the moon. This was this was when the Russians had sent one satellite out here, took one picture, and they drew a map out of that. But it's just crazy to me that we're seeing the transition from not even knowing what the other side of the moon looked like to a chance where we send people throughout the solar system. Okay, thanks.
I think that was a really excellent tool. Thank you.
Any more questions?
Oh, yeah.
Question, you point out New Zealand as being well placed, but why wouldn't they launch from, if they're wanting a polar orbit from California, why wouldn't they just use the...
Well, I think there may be launch sites, around the world that you go to, and it may be that you use Elon's or Jeff Bezos' rockets, just like Air New Zealand uses Airbus airplanes. But I think that a lot of the concepts of and all the thinking about everything you need to survive in this environment and all the different aspects of what you would do in space, I think there's a potential role for New Zealanders to be involved with that. Now, where you actually launch from, it may just depend on what's the easiest, I think, you may go to Florida for your departure, but the entire, I know of one person that wants to buy 5 of Elon's rocket flights. And we're helping one New Zealander who plans to start making solar arrays on the moon, and he's making a company out of that. And so there's all this potential that's just emerging in the next couple of years about these projects, and that's the idea.
Well, New Zealand is a good launch site because it's equatorial and polar.
Yeah, I mean, it's good, and there's a lot of Earth orbital activity that New Zealand is going to be involved with. I'm looking forward to lots of frequent launches from Rocket Lab from New Zealand.
Is it from Macleod?
Yeah, from here. And also there's there's still an opportunity, I think, in Christchurch for I'm hoping for suborbital flights from down there because I think there will be a lot more beautiful to launch from there than from Texas, where you just see flat gray.
Yeah, and Eric, one point as well is that the air traffic is definitely a lot less here than if you're basically launching from either California or Baikonur or all of the other equatorial ones where just the air traffic is so crazy. Well here, there's nothing in the east and there's nothing in the south.
Yeah.
What is different compared to the 70s and 60s now that we should go into space now?
Yeah.
Why do you see there's more enthusiasm right now?
Well, I mean, part of one area is that there's this transformation of exponential technology, so that this thing is equal to 60 Cray supercomputers, and it's more powerful than all the computers used in the Apollo program. And so that allows things like the rocket's first stage to land because the computing on board is so powerful, and so that allows you to do all these things much cheaper than what was envisioned in the past. Like the space shuttle was supposed to be cheap. It was sold as $4 million a flight. But it turned out that after every flight, you had to take apart the entire engine and inspect every blade and put it back together. And it cost $1.6 billion per flight instead of $4 million. And so that's a big difference. And so if we can actually get down to $7 million a flight with hundreds of people, then you're talking something almost approaching air travel.
But why wouldn't they need to pull apart these SpaceX engines and analyze them each time?
Yeah, well, they've looked at them and tested them, and they've actually reflown, and so
Yes.
they're working it out. And so it really it depends a lot on, and also, you know, like Rocket Lab has done a very smart thing. They took, normally engines are driven with pumps that are driven by the fuel and oxidizer and are very unstable, and that's why rocket engines blow up a lot, is you're trying to drive the pump with this burning, you know, the excess propellant. Whereas Rocket Lab just said, oh, actually electrical batteries are now more powerful enough, you can just separate it out, just have a battery, drive the pump, and it simplifies the whole thing, and that makes the rocket engine a lot cheaper. And that's why they're able to, they're actually able to 3D print their rocket engines and do about 20 every week. So. Okay, thanks.
Well, yeah, thank you so much for coming. Just wanted to point out, who came here for the first time for the meetup for Space in Mountain? That's awesome.
Wow.
That's great. So just to let you know, we actually do this every month. We either, you know, we have talks or presentations by people that we know either were coming to New Zealand or are really specialists in space. And you can find us basically on spacebase.co, which there's now a calendar for any space activities that we're kind of collating in New Zealand. If you're interested, that's kind of the place to look for it. Also a Facebook group called Spacebase NZ, where anything that's related to space on New Zealand, that's kind of like where we post things as well. So yeah, thank you so much for coming.